real-world application of calculus throughout different careers.
Welcome to the Marcellus High School Career Fair. At this booth, you'll learn about what marine and ocean engineers do. An ocean engineer is responsible for the design, plan, and development of devices used by oceanographers and marine biologists. They create instruments that can stand up to being submerged in salt water, withstand storms, and stay at sea for long periods of time. Calculus can help marine engineers determine how certain variables will affect their boats over time. Differentiation and integration are particularly useful. It's needed to prepare system layouts and detailed blueprints of things like boats and oil rigs. Ocean engineers mostly work in a collaborative setting with other kinds of engineers. They must understand the related natural resources found within the ocean and the atmosphere. Calculus is used to study the tidal current patterns of the ocean and atmosphere as well. These jobs require travel and work in uncomfortable and even dangerous conditions, including ships and in submersibles. They also study ocean structure dynamics, buoyancy, wave mechanics, coastal engineering, and mineral resources. Derivatives and summation would be useful and used by devices created by marine engineers which sense underwater objects and seafloor formations, and they measure underwater earthquake activity or study tides. Jobs are found in the government, military, oil, conservation, or navigation industries. A strong base in math and science, especially in physics and calculus, is needed to study and succeed in this multidisciplinary career path.
In the field of chemical engineering. Chemical engineering is the study of operation and design of chemical plants as well as methods of improving production. Chemical engineers use calculus in their everyday life, such as mass transport, heat transport, momentum transport, thermodynamics, and reaction kinetics. They also analyze graphs of chemical reactions and rates, which they use calculus to do that, and they also use calculus to design certain products that are used in the lab. There are multiple different subfields of chemical engineering, such as biochemical, biomolecular, genetic, materials, and microbial engineering, and each one of these different subfields use calculus in their own unique way.
Hi, thank you for coming to my booth. So this is the epidemiologist booth. I'm an epidemiologist, and so I work with studying and trying to cure different kinds of diseases. So do you guys have any questions about epidemiology or anything like that? Yeah, so I was just wondering, how does calculus connect to your everyday life? Awesome, yeah, so that's a great question. Epidemiologists and calculus really connect when it comes to curves and graphs and stuff like that. Obviously, graphing is really important when trying to figure out when diseases are happening and the reoccurrence of them. But in similar things like COVID, you probably heard about flattening the curve. We have to look at the rates at which things are growing, increasing, why they're increasing, and all the patterns and stuff like that. So it's really important that you have a good handle on curves and everything. Oh, okay, awesome, thank you.
Welcome to the Public Health Administration career booth. As a public health administrator, your job is to educate the public on the prevention of health problems. Pretty simple. You got any questions? I've got a question. My love, my dream is calculus. However, does public health and calculus combine? That's a really good question. Similarly to our epidemiologist, calculus can be used to track the different rates of diseases. It can also be telling where they're going to go, where they've already been, and this is really important because then public health administrators can go into those locations and educate them how to prevent those diseases from spreading. So now you know your passion and dream of calculus can be applied to public health.